Today, we're diving into the crucial world of version control and collaboration, essential for any modern developer. Specifically, we'll learn how to effectively manage your code using powerful tools like Git and GitHub. Let's explore the core features of Git and GitHub, understanding what makes them indispensable for development. We'll understand their distinct but complementary roles in modern software development workflows and team projects. First, what exactly is Git? It's the fundamental system behind our version control efforts. Git is a distributed version control system, meticulously tracking every change you make to your files. It allows for branching, merging different lines of development, and keeping detailed logs of all changes. Now, what about GitHub? How does it fit into this picture with Git? GitHub is a web-based platform that uses Git, designed for seamless collaboration and project management. It offers remote repositories, facilitates pull requests for code review, and integrates CI/CD tools. Let's delve into the key concepts that form the building blocks of Git and version control. Understanding these foundational terms is crucial for effectively managing your code's history. First, a repository is your project's storage location, containing all code and its complete history. This repository can be either local on your machine or remote, shared with others online. Next, a commit is like a snapshot of your changes, marked with a unique ID and a descriptive message. Each commit records specific changes made to your files at a particular point in time. A branch represents a separate line of development, letting you work on features in isolation. This means you can experiment and develop without impacting the stable main codebase. The merge operation combines changes from one branch into another, integrating new work. Merging brings together new features or bug fixes developed on a separate branch. The staging area is a temporary buffer where you prepare files before they are committed. It allows you to select exactly which changes you want to include in your next commit. Finally, a remote refers to a repository hosted on a server, enabling team collaboration. This remote repository, often on platforms like GitHub, is essential for sharing and collaboration. Now, let's walk through the practical steps of setting up Git and GitHub on your system. These are the crucial initial steps to get started with effective version control practices. Your first step is to install Git on your computer, which is straightforward. You'll download Git from its official website and follow the installation instructions for your operating system. Next, configure your username and email globally in Git, identifying your contributions. These commands set your name and email, which will be associated with all your future Git commits. After Git, you'll need to create your own account on the GitHub platform. Simply visit GitHub.com and sign up for a new account to begin collaborating. To ensure secure authentication for your projects, generate an SSH key on your system. This command creates a secure pair of keys, enhancing the security of your GitHub interactions. Finally, add this newly generated public SSH key to your GitHub account settings. Copy your public key and paste it into the SSH and GPG keys section of your GitHub settings. We'll now explore some of the most common Git commands, absolutely essential for your daily version control workflow. These are the fundamental commands you'll use regularly to manage your projects and collaborate effectively with others. First up, let's learn how to initialize a new Git repository for your projects and begin tracking changes. The git init command creates a brand new Git repository in your current directory, ready to start tracking your project's changes. You simply type git init in your terminal to begin tracking your project's version history and set up Git. Next, we have the command to clone an existing repository, which is crucial for joining a team project. The git clone command copies an existing remote repository from a server onto your local machine, including its entire history. You'll use git clone followed by the repository's URL to get a local copy of a project. Now, let's look at how to add files to the staging area before making your next commit. The git add command stages your changes, preparing them for your next commit. you can add specific files or all modified files. Use git add with a file name to stage one file, or git add dot to stage all changes easily. Finally, let's cover how to commit your staged changes to your repository's permanent history. The git commit-m command records your staged changes into the repository's history, along with a descriptive message. You'll type git commit-m followed by your message in quotes to save your changes permanently. Now, let's tackle a common challenge in version control: effectively managing merge conflicts when they arise. The first crucial step is to identify precisely where these conflicts have occurred within your code files. Next, you'll need to manually edit the affected files to carefully resolve the conflicting lines of code. Once you've fixed the issues, you must mark those files as resolved, indicating the conflicts are fully handled. Finally, you can complete the merge operation, integrating all the changes smoothly into your branch. Let's explore some common branching strategies, crucial for organizing team development and collaboration workflows effectively. These structured approaches help teams collaborate efficiently and manage different aspects of a project simultaneously. First, we have Git Flow, a robust model especially suitable for large projects with strict release cycles. It employs distinct branches like main, develop, feature, release, and hotfix for a highly structured workflow. Next, consider GitHub Flow, which is a simpler and more lightweight branching strategy for teams. Here, the main branch is always deployable, and you use short-lived feature branches for new work. Finally, we'll look at trunk-based development, emphasizing a single main branch for continuous integration. This strategy involves frequent, small merges directly into the main branch, ideal for high-velocity projects. Let's now delve into the key stages of collaborative development, essential for successful team-based projects. These are the critical phases that teams navigate to ensure efficient and high-quality software development. The feature branch workflow involves creating isolated branches for new features, preventing disruption to your main codebase. Code reviews involve peers systematically examining code changes to ensure quality and adherence to coding standards before merging. Continuous integration, or CI, automates the testing and validation of code changes, ensuring stability with every update. Continuous deployment, or CD, automates the release of thoroughly validated code directly into production environments. All right, let's wrap up our discussion with a quick summary of everything we've covered today about version control. Here are the key takeaways, the most important points you should remember from our session on Git and GitHub. Remember, Git is your powerful distributed version control system, essential for tracking all your code changes and project history. And GitHub, of course, is the web platform that utilizes Git to enable truly seamless team collaboration and project management. Our core Git concepts include repositories, commits, branches, merges, and that crucial staging area for changes. Effective branching strategies, like Git Flow and GitHub Flow, are key to streamlining parallel development efforts within your team. For collaborative projects, structured workflows, thorough code reviews, and CI/CD pipelines are incredibly beneficial. Finally, GitHub Actions helps automate your testing, building, and deployment processes directly within your project repositories.